and we can chop off the beginning when we need to, but are y'all ready to let people in?
Yep. So all I will say is we'll give everybody 30 seconds to log on, and then you guys can take over from there.
Okay.
Here we go.
Good afternoon. We'll give everybody about 30 seconds to log in, and then we'll get started. Okay.
Hey, Yvonne. Hi, Chris.
Good afternoon.
Good afternoon.
Hey.
So I guess
Hey,
we can
Adriana.
start.
Good
How are
afternoon.
you? Good afternoon.
Hi,
Good.
Hey,
Okay.
Shipping.
Oh. Hi, Tammy.
Brunella and Adriana, we'll turn it over to you and we'll let you get started.
Okay, good. So hi, everyone. Welcome to the wood quality session discussion. So thank you for attending this session and being a part of the first Product Society Virtual International Conference. So I'm Brunella Rodriguez, and as a session organizers, Adriana and we are really glad to be the moderators of the session today. So Adriana, thank you for accepting the work that you work with me and prepare to this session. So guys, our idea for this session today is being an open conversation where your questions can be answered and also your ideas can be shared amongst peers here in wood quality. So feel free to send us your questions using the chat box. And also, if you feel comfortable, you can raise your hand and open your microphone and ask your question.
Yes. Hey, I'm Adriana. I want to thank the program coordinator, Ms. Jennifer Whitlow here, who conducted the schedule, provided information and clarified all our questions. Thank you, Jennifer. I also want to thank Brunella, my partner in this endeavor, who invited and encouraged me to organize this session together. Thank you, partner. We should do more work together. First we have some general announcements from the conference organization. As a reminder, this session will be recorded, so we ask that you keep your computer muted unless participating in a discussion, but feel free to submit your questions at any point using the chat box feature here in Zoom, but also later at the discussion box in each individual presentation page. And all the presentations uploaded here will be available through May 2022. So don't forget to save the email in which you received your personalized access link. So we proposed this wood quality session to discuss the wood quality control process over the from the forestry all the way to the industry, in a way to attend both the customer satisfaction and also comply with sustainability standards. So we suggested some topics, and we are glad that we were able to cover the majority of them with the presentations and the posters, and hopefully we will have a rich discussions that will come from your questions. Brunella, sorry, you're muted.
All right, I'm sorry. So before we are going through the questions for sure, I would like to give you a brief introduction or a brief overview about all the presentations that we have received. So I will start with the invited speakers, and I would like to say thank you, Dr. Shipping Wang, Dr. Ivat Dixon. So Ivat now is in New Zealand, maybe it's 7 a.m. there, and thank you so much to be here with us. Thank you also to Dr. Gabby Bombadilla and Dr.
Brunella's frozen. Let's give it just a second. Adriana, we may have to shift over to you.
Dr. Gab discussed about the properties needed to evaluate the wood quality.
Oh, boy.
Okay, so I think, oh, is
We
she
lost-
off?
She's back.
She's
Okay,
back.
again, Brunella.
You're muted.
All right.
There we go.
Sometimes if you'll turn off your camera but share your screen, that will help. It takes up more bandwidth if you're doing both.
Okay.
Okay. Did you finish with your presentation? Because
Not
you were
yet.
frozen.
So let me know if it's sharing, Adriana.
No, not yet.
Okay, let's try again. And how about now?
Yes, okay, perfect.
Okay, so I don't know where I stopped it. Can you say where?
Yeah, I think you should start from the beginning talking about Dr.
Okay.
Gabriele. Yes,
Okay, I'm sorry.
I'm
So
sorry.
I just want to give you a quickly introduction about the presentations, and I will start with the invited speakers. So the first one was made by Dr. Gabby Bombadilla and also Dr. Ruben Shimusk, and they give us a presentation about wood quality for structural lumber products. There was an excellent overview about wood quality required for different sectors of the forest products industry, and especially for her topic, the structural lumber, she discussed about the properties needed to evaluate the wood quality in this use, and also how we can handle with variability. Dr. Wang gave us a brilliant overview of some advances, non-destructive evaluation techniques that we can use to access the wood quality of standing trees, and also to have to maximize the utilization of forestry resource. These techniques were silvscan, near infrared spectroscopy, acoustic waves, and resistance drilling. So his presentation was very clear about the importance of understanding the relationships connecting with wood structure, genetics, silviculture, and sure, the end use. So Dr. Eva Dixon, so she had the opportunity to share with us two really good investigations. One was in Michigan State, where she works with sugar maple trees, and the other one in New Zealand, where she works with radiata pine trees. So we could see in her presentation a couple technologies previously mentioned in Dr. Wang's presentation, and how was interesting to investigate the wood density and also the parameters among different silvicultural systems as an indicator of wood quality. And our last invited speaker is Dr. Alex from the FPL as well. And we also proposed in our topic, wood quality topic, covered the automated microscopic wood wood identification system. So we were gifted by Dr. Alex because he gave us a presentation about the potential and the pitfalls of these technologies for wood quality in general, and also for wood identification more specifically. Yeah, that was.
Yes. So, and to complement this automated wood identification topic, we had two other presentations, one by Adam Wade and the other by Dr. Frank Owens, showing the application of this technology using North American and Peruvian wood species respectively. So don't miss those two presentations. There is also a poster by Fanyu Wu related to automated wood identification, but then focusing on microscopic images. And we noticed that this automation subject is trending. And we had another poster presented by David Milstead showing an automated system being used not for wood identification, but in wood quality, focusing on evaluating wood checks, among other things. And to end this overview, we have two other posters showing typical examples of wood treatment processes used to improve the wood quality for its final use. So one is related to the influence of the layout and adhesive in mixed cross-laminated timber, and it's by Keom Ho Kim. And the other is the study of natural durability and treatability of Quercus palustris planted in Uruguay by Claudia Marcela Ibanez. So we hope you had a chance to check out all the pre-recorded presentations, but if you didn't for some reason, they are going to be available in the platform after the discussion, as we previously mentioned. So thank you for choosing our session and submitting your presentations.
Yeah, I'm glad to say that our invited speakers is already here, and maybe we can start our discussion. So we know the wood science has gone a long way in the last decades. So just for start this first round of questions and discussions, we would like to hear from each of our invited speakers. What are the topics for you that could be important in the future related to the wood quality? So, I mean, what will be the highlights on wood quality topics coming up during the next 10 years? We would like to hear from you for your research area and topics related to wood quality. So feel free to give us your thoughts about it. Maybe we can start with Dr. Shiping Wang.
Hi, Brunella. Hi, everybody. Glad to see a lot of familiar faces here. Well, Brunella, you already gave a pretty good summary about my presentation. Basically, it's just the overview of some of the non-destructive evaluation technologies for assessing wood quality of standing trees. We all know wood quality is pretty important issue, and especially we're facing resource change, and we are dealing with more and more dealing with small diameter trees with a huge variation in the quality. So assessing wood quality is a critical procedure in the operational value chain. So of course, there are many different approaches or technologies can be used for this application for assessing the quality. But my talk just focused on 4 emerging technologies. Silver scan, many of you already know, probably have used before, which is laboratory instrumentation specifically designed for characterizing wood and fiber properties of plantation trees. But it doesn't require take core samples from trees. and to do scanning and post-analysis in the laboratory. Similarly, near-infrared spectroscopy is also a laboratory, pretty much a laboratory instrument. And you need to take core samples, bring back to laboratory, doing the scanning analysis. And I see Professor Brian Way is here. He's the expert on that. The other two acoustic waves and resistor drilling. These are portable tools that can be used directly applied on trees. So there are different technologies available, and they are currently being used in the field by research community, but also forest companies. Looking forward, I think the technology still need to be continuously to be improved, and we want to improve the precision, the accuracy of the technology, but also I think that probably in the future would be the big focus would be develop wood quality models based on the non-destructive measurements, non-destructive parameters. So we need to develop more models, comprehensive models to predict the wood and fiber properties, and that can be linked to different applications, either for wood utilization, or it can be for forest management, silvicultural treatment, and also genetic improvement. So a lot of applications. So I'm be happy to discuss any question you have, and we'll go from there.
Yeah, maybe we can hear from Dr. Alex. How will be the highlights in your idea about the wood quality for the next 10 years?
Hello, yeah. Well, I think what I'm excited about is the prospect of different kinds of methods to rapidly characterize and then start to bridge the gap between the small scale stuff, because I mean, I'm a wood anatomist by training, so I'm inclined to want to look at things under magnification and then see if we can infer something about their larger scale properties. And people have been trying this in various ways for several decades now, but I think with the advent of some of these computer vision techniques, we have the ability to do rapid characterization that is actually quite inexpensive and try to correlate that back up to large scale properties. So I think something like that would be really interesting, but that would be, of course, after we've already cut everything down, right? So when Xiping's talking about the standing tree, we're not going to be able to solve any of those problems on our side coming at it from the perspective that we're coming from. But if we could characterize material that's already felled and do that in a rapid way, and with it, if it's an image-based thing, that would be also probably fall under the non-destructive category. So something like that would be a pretty exciting area, I think.
Good, thank you. So maybe Dr. Ruben Chimusk or Dr. Gabby, feel free to share with us your thoughts. Or
I'll go ahead. The question about wood quality issues into the future, I put sideboards on my comments that it relates mainly to southern pine, and southern pine relates mainly to loblolly pine. But our timberland and our sawmills have attracted a lot of investment from multinational companies, and in particular, Canadian companies have invested millions of dollars and hundreds of millions of dollars into production technology in the southern pine region. That's good. I think they're viewing this area as the sustainable wood basket into the future. About 10 or 20 years ago, Wall Street encouraged the vertical deintegration, that is divorcing the timberland ownership from the conversion ownership, and there's a tax savings if a company becomes a real estate investment trust and sells off their sawmills or vice versa. I think that made sense on Wall Street, but in the case of our forest land, when we fall asleep, the trees keep growing. So there's no way to constrain the supply. The pine trees grow 4 or 5% in volume per year. So currently we have what we might think of as an economic oversupply of pine trees. We've done a good job of trying to make them more uniform with intensively managed plantations. Those grow quickly. That particular wood quality has a couple of risk factors. One being when they're really intensively managed, the strength and stiffness of the wood is not as high as naturally managed stands. So we've done some testing, and lumber cut from naturally managed stands is about the same as the lumber cut from similar forest management from 1964. So the basic wood fiber is the same as it was 60 years ago, but in intensively managed plantations, that's not the case. And we have a couple of other risk factors we see. One is severe weather events. If we have more and more severe wind events and storms, those blow down trees. There's not a lot we can do to prevent that. Thinning pine trees is part of the management regime, and that adds a risk to that their health. When they are planted more closely together, they seem to weather the bad storms a little bit better. Another wood quality issue we'll see in the future is the risk associated with monoculture. That when we select our trees for fast growth or knot size or density or something, and if we develop the genetics that are very, very close to each other, the downside is we have a risk that a pathogen may come and cause a lot of damage. So we have some beetles and we have some fungi that really attack our pine trees. So I think forest health or the fiber health, it may be an issue into the future. Thank you.
Thank you, Dr. Ruben. So Yvette, feel free to give us your thoughts. Sorry.
Thank you, Brunella. I'm actually really excited from what I hear from both Robin and Shaping, because some of my thoughts are actually very similar. As a silviculturalist, I'm primarily really interested in how to grow trees and how to manage forests. And wood quality is just one feature that we grow these forests for. And so I'm really excited about the non-destructive tools that we have now, that we can start to actually look at wood quality in these standing trees without having to destructively test them. And we can start to understand how wood quality changes through time as these forests grow, and therefore start to understand more about how our management actually affects wood quality on a shorter time scale. So instead of having to wait for an entire rotation, we can start to look at it in situ. We have really similar problems or challenges coming our way in New Zealand, as what Robin was describing in the southeast of the US, where we're worried. We have primarily one plantation species. We are worried about climate change and the risk of monocultures. We have a move towards shorter and shorter rotations. But the ultimate question is, how do we get good wood quality with these shorter rotations? And that requires understanding a little more of the physiology about what's happening in these trees. And finally, we're moving to a greater diversity of species because of these issues with, or potential issues with monocultures. And so we're starting to look more at species that we haven't looked at before and trying to understand what's happening in terms of their growth and management, but also the wood characteristics as well.
Yeah, that's very interesting. So I have been working with monoculture, especially eucalyptus trees in Brazil, and we are having all that situation that you mentioned about the climate changing, and especially I had the opportunity to work with an abiotic stress, and that's really that's a big issue for sure. Good. So I don't know if someone from the audience would like to ask any question or give yours any discussion, feel free.
Yeah.
I would just
Oh,
like to
good.
make a comment that sometimes I feel, and I see here many forestry engineers, and it's nice that they are on wood products, but sometimes, and maybe you can give a feedback on that comment, is the gap between the foresters and the wood products. You know, seems that, and I see in Brazil, for example, I'm from Brazil, and I'm here in Mississippi State as a faculty member, but I see that there we prefer to change the genetic of the tree, and here is more on the industry. So sometimes I think for the wood quality, both the forest and the industry should talk more, because maybe the forest people, they don't know exactly what we need. So I just have this feeling that we need to fill up this gap, you know, between the forest and the industry to have a better wood quality. So it's just a thought. Thank you.
Okay, we have one question here from Brian. So I will read this question. By genetically improving for quality, we are trading off for worse forest health. In other words, if we genetically improve on a wood quality trait, do we unintentionally change the resistance to forest pests? And I think this would be addressed to Yvette, maybe.
Certainly, I can kick this off. I don't think we have strong evidence that it's an either or situation, that we necessarily have to trade off one for the other. In fact, my understanding of breeding, at least in radiata pine in New Zealand, is a lot of the time, yes, we are breeding for better forest health, but that actually gives us higher productivity in terms of just growth rates. And it may give us better wood quality as well. So I don't think it's necessarily a trade-off. That question, though, is one that I'm trying to look at in radiata, where we're looking at what is the influence of genetics versus the environment versus our management on some of these wood quality characteristics. And we here at Scion are trying to move more and more into those kinds of areas to try and understand that.
Thank you.
So I'd like to add to Brian's. I see that these high breeding, how may I say that? How this high improvement on breeding genetics, it's more for me correlated to the abiotic events than biotic disease, like you asked about first pests. So when, for example, in Brazil, we have a really high level of improvement in eucalyptus forest for pulp and paper production. So what we want for wood quality for this end use, we want less lignin. So sometimes we have this event that Dr. Robin Shimuski mentioned about the wind, when the trees are suffering this blow down. And we have this situation here in Brazil, and just would like to add this situation about the breeding.
I'll just add a few points. That's really good question, Brian. From my understanding, in the genetic improvement program, their primary goal is to get a healthy forest, but also improve the tree growth. That's their primary goal. Years ago, I was invited by a company in Chile Arauco to visit their research facility, Bioforest. Their research primarily focused on genetic improvement. So in the past couple of decades, their primary goal is to increase the yield. They have a goal, they set a goal for each year, increase a certain percentage in the yield, in the tree growth. But they have been overlooking the wood quality issues now, so they are catching up. So because the wood quality becomes the issue, so now they've been adding wood quality goals to the genetic improvement program. So they want to improve the quality also. In that way, they starting to doing some non-destructive measurement on the trees, looking at the fiber properties, and see how the new clones, the new plantations can be improved in the wood quality.
Okay. Thank you, Dr. Spring. We have another question for Dr. Alex. So one of the automated wood identification is one of your research topics, right? So the question is, how far are we to view this technology being used and making positive changes in the wood identification field?
Yeah, so there are a range of different systems that are out there. I can speak most authoritatively about the xylitron and xylophone because they were developed here at FPL. Through my program, we have 10 xylotrons being used to inspect charcoal trade in Europe. We have 14 xylotrons on the ground in Ghana being used by the Timber Industry Development Division there for monitoring export and controlling species identification for exported timber. We have units in Peru, in Colombia, and then we're working actually actively with the Philippines and FAO, and the Philippines is actually implementing the xylophone-based version of this technology for kind of a similar program in Ghana. So it's happening at kind of on a country by country basis at a small scale. With the development of the xylophone at a much lower price point, we're hoping to see international uptake go up. And then we've been releasing all of our system designs and everything as open source. So prior authors and other people have kept everything closed or have been trying to market a commercial product, and we've been doing everything open source with the intent, at least, that other people can take this up and start to implement it, and ideally make improvements that then we can leverage on our own side and have everybody doing this stuff well.
Yeah, so you mentioned this several countries. So what other research group or groups other than yours do you think are making real advancements in the automated wood identification systems? And what are they doing?
Well, there's an impressive program. They haven't published a lot, but there's an impressive program in Indonesia, actually, and they have their own system that's smartphone based that they have deployed around Indonesia. There aren't as many academic details available about that system because they, I think, have been more emphasizing doing the work rather than and the boots on the ground real work rather than publishing, which is. It's laudable, but it makes for an awkward discussion in an academic context because sometimes we don't have access to performance metrics or system parameters or other questions that we would want to be able to answer and evaluate from a technical side to see, are their technologies something that we would want to implement or we would want to take up, or vice versa. And when we don't share the details well, it makes it more difficult to do that. But yeah, so the Indonesians have an active independent program. There's been some work in Malaysia and a separate program. There have been a couple different groups in Brazil that have done some nice work in this area. So a lot of different groups have made different degrees of advances and laboratory and field-based approaches to this stuff.
Okay, thank you. Any more questions? Anybody want to add something?
I have a question for Yvette for her presentation. I thought it was interesting that you saw that there wasn't an effect of longitudinal stress waves on density. And I actually saw the same thing on ponderosa pine in one of the projects I was working on. But I wonder why, if you have any thoughts as to why there was an effect or a prediction power of the transverse acoustic velocity on density.
That is a really great question, Damon. I guess they are measuring two different parts, two different factors, really. The transverse is probably picking up on things like decay, I'm thinking, within the trees. And particularly when you're looking at those old growth trees and sugar maple, there are a lot of those kind of bigger defects in there because they are so old. So that would be my kind of first gut response. But I wonder if my colleague Shaping Wang might have some other ideas. I don't know.
Yes, that's a very good question. For assessing trees using acoustics in the past, we have been mostly focused on softwood species. And this is probably the first or second study done in hardwood, especially the sugar maple trees in this project. The diameter quite large compared with softwood. And I remember there's a lot of variations in the tree diameters. So one of the issues with acoustic measurement in trees, especially longitudinal, there's a debate about what we are measuring actually. Is it a one-dimensional wave or three-dimensional waves? That is affected by the size of the tree. We already noticed this problem. So we already completed a study, and we've done some simulations, wave propagation simulations. And yeah, as the tree diameter change, the wave behavior will change. Consequently, the velocity we measured on trees is diameter dependent. So if we compare the tree measurement with log measurement, which is much more accurate, then we needed to do some adjustment based on the size of the tree. So we haven't gone that far yet because we did preliminary analysis. So the next step will probably look into the size effect, the diameter effect on the velocity measurement. And if you're interested in this issue, so we have two papers published in the Wood and Fiber Science Journal. Part 1 and part 2 specifically talk about the diameter effect and also the juvenile wood effect on wave propagation.
Okay, so good. Brian, so do you have other questions? Feel free to open your microphone.
Yes, I just wanted to add that, and I think Shiping, you were part of this work with my former grad student, Charles Essen, but we did some work where we found that the sound wave follows the microfibril angle. So if you think of the microfibril angle as being the road, it travels down, and the cellulose acts like a conductor of that sound, while the lignin acts as an absorber. And so we found that we actually found that when we analyzed density along with cellulose and lignin and hemicellulose and microfibril angle all in the same analysis, we actually found that cellulose was actually more influential than density for the sound wave. And so we published that in the Wood Science and Technology Journal.
Yes, Brian, that's a really great study because I think that's probably the only paper looking into the connection between the sound velocity and the wood chemistry. microscopic properties. So it's really good study.
Thank you.
Thank you, Shiping. Thank you, Brian, for your adding. So maybe we have 1-2 minutes for the last question for Tammy. So this was addressed to Dr. Wang. And could you talk more about effect of moisture content on NDT measurements?
Sabrina, you're talking about me? Ask me to.
Yeah, I'm sorry. So yeah, a new question came from Tommy, and she wants from you to talk more about the moisture content related to NDT measurements.
Yeah, that's a good question too, because of course, moisture content affect physical and mechanical properties of wood, and accordingly, acoustic properties will be affected. But the most significant effect is occurring below fiber saturation point. So for dry wood, yes, slightly changing moisture content will change the acoustic velocity significantly. There's many studies has been done. So there has been some models can be used to make adjustment. Regarding standing tree measurement, because we are dealing with green wood, the moisture content is well above fiber saturation point. And we find when the moisture content above fiber saturation point, its effect on wave propagation, it's minimal. So we basically, we just ignore the moisture effect in trees. Well, one thing to keep in mind, if you're testing beetle kill trees, or to be totally different, that will mess up that. That's, even we did a study on beetle kill trees, and we run into these problems because when tree dies, it dries up, and supposedly, the wave travel faster. But at the same time, timber died, it will deteriorate with the time. So there's two opposite effect. So that makes acoustic assessments more difficult, in my opinion.
Thank you, Dr. Shipping. Sorry, guys, but I need to interrupt the questions and discussion. We are coming for the end of our session, unfortunately. So I would like to thank you all here for being here today and gave us this great discussion, especially for our invited speakers. Thank you, Dr. Shipping Wang, Yvette Dixon, Dr. Alex, and also Dr. Ruben Shimusk and Dr. Gab, who made the presentation.
Yes, and thank you. I would like to thank everybody again, and also all the invited and the proposed presentations here. Thank you again for coming and contributing to this discussion. And if you have further questions, please contact us. Our information can be found in the conference website, and also direct the questions to the presenters here at the website platform. Thank you again.